Here we go, everybody. 3.5. All right, guys, listen. When I was taking calculus, and then even for like the first 10 years that I was tutoring or teaching calculus, I was always like, man, derivatives of inverse functions are so confusing. They're not so confusing, okay? We're going to be all right. So we're going to talk today about derivatives of inverse functions, but first I need to remind you what an inverse is. So right now, we're not going to talk about calculus at all. We're just going to talk about inverses for a minute, okay? All right, so over here we have the graph of a function, f, and its inverse. That little -1 means inverse, you guys. It's not an exponent. It does not mean to the -1 power. It's an inverse, okay? Here's how inverses work. They are symmetric along this middle dotted line. So, for example, let me show you an inverse here. X to the third and cube root of x are inverses of each other. They're like opposites, right? The heck is the cube root? Here we go. Cube root of x. These are inverses, okay? So cool. And if I draw the line y equals x right through the middle, make this nice and dotted so we can kind of see it here. All right? This is symmetric around that line. All inverses will be, okay? All inverses are going to be symmetric like that. So, you can see that these are symmetric. And what happens is, like, any point that is over here, AB, the inverse point is over there, BA. Flips the points around. That's a really important concept for this, okay? So if one graph contains AB, the inverse contains BA, and so on. All right? And it makes this cool thing. So it says, do you see the relationship between the slope of the graph of AB and the slope of the inverse at BA? Okay, it's like, let's see if we can like zoom in a little bit and see. You guys see that the slope here would be like that, maybe? Ooh, that was a crappy slope. And the slope would be like that, I guess. Do those slopes look like they could be reciprocals of each other, maybe? All right. Okay, so let's look at this example here. Okay, we're going to start with this function. F is square root x. Here we go. I know what that looks like. 0, 0, 1, 1, 4, 2. That's the graph of square root of x. Okay. Find the inverse. All right, you guys, the way we find inverses is we switch x and y and we solve for y. So instead of saying y is the square root of x, we say x is the square root of y and we solve it. And the inverse operation for a square root is squaring something. So the inverse is x squared equals y. Now, the problem is the graph of x squared, you guys, looks like this. Which is like cool and all, but that does not look like inverses to me. That does not make me feel happy and make me, sleep well at night. That looks terrible, okay? Even though the square root of x, I should put squared, the square root of x and x squared are inverses of each other. Does that look nice and happy? Oh, that looks so crappy. It's horrible. Because the problem is that if I flip this and the square root comes down here, it's not a function anymore, okay? So I got to put a domain restriction on this. I think we've talked about this. We definitely talked about it last year if we didn't yet this year. But if I just say, okay, fine. How about only the numbers bigger than 0? Ooh, I love that, and that helps me sleep at night. Okay, looks beautiful. I love it. So my domain restriction right here, so it's basically, let me write it a little bit nicer. Y is x squared, but x can only be greater than or equal to 0. And then in that case, it looks like this. 0, 0, 1, 1, 2, 4. Boom. Whew, beautiful inverses. Okay? Okay, now it wants me to, so sketch the graph in the same coordinate plane. Did that. All right. Differentiate both of them. Yikes. Okay. F of x was square root x. F inverse of x was x squared with a bit of a restriction. Okay, let's derivative that. Here we go. All right, this one is going to be 1/2 x to the -1/2. Okay, this one, now, I don't know, do we write it like that? I actually can never remember. F inverse derivative, does it? Yeah, it puts F inverse with a derivative right there. That's so weird, huh? I'll show you guys what I do to make that not be so confusing. But anyways, okay. F inverse derivative, right? The derivative of that is 2x. Okay? Okay, next step. Find the slope of f at the point 4, 2. Well, f prime at the point 4, 2 is 1/2. 4 to the negative 1/2. Okay, 4 to the negative 1/2, that's a square root of 4 on the bottom. That's a 2 on the bottom, so it's 1/4. Okay, let's do this one. F inverse prime at the point 2, 4. Because remember, these are reciprocals, right? 4, 2, 2, 4. So actually, I want to plug in the x coordinate right here, which is 2, equals 2x, which is 4. What conclusion can you make about these slopes? Oh my goodness, guys, they are reciprocals. Okay? This is just an example to teach us that at any given point, whatever we got here, let's just use like that point, the reciprocal slope will be there on the opposite point. Okay? So if we read this, since m is changing y over changing x, it should make sense that switching x and y should produce reciprocal slopes, and it does. All right? If you understand that, this stuff is not too difficult, but here's how this works. Okay, derivatives of inverse functions. So we have this point, okay? We have this point, and it's the point AB on the graph of f, and it's the point BA on the graph of f inverse, all right? The way it works is the derivative of the inverse at B is the reciprocal of the derivative of the function at A. Okay? So that's a kind of weird way to write it, and I used to always be like, oh crap, I gotta memorize f inverse B 1 over f inverse A, and it was like so confusing to me. Like I literally hated it. Okay? First of all, the f inverse thing kind of throws me off a lot. So what I will do oftentimes is instead of calling it f and f inverse, I'll call it f and g. Okay? And I'll be like, okay, g prime and f prime. And then whatever point in here, you guys, I just remember it's like the x and the y coordinate. All right? Derivatives have reciprocal slopes at inverse points, or at image points. Image points are the ones that flip like that. Okay? When finding derivatives, do not use the same x value for f and f inverse. It hardly ever works. It like never works unless it just so happens that the inverse values are the same. Okay, so check it out. F and g are inverse functions. All right, it didn't tell me anything about g, but f and g are inverse functions. Blah, 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 blah. I just shown on the table. Okay, from the information, find each of the following if possible. So let's look at that. It told me nothing, like literally nothing about g. I don't know anything about it. I just know that they're inverses, okay? So let's start with f. I feel like that's going to be a little bit easier. Can you guys tell me what points are on the graph of f? Well, these points right here. So the points are, if x is -1, y is 1. If x is 0, y is 2. If x is 1, y is 5. From there, can you tell me what the g points are? Yeah, because they're just the image points, right? We just flip x and y. So this would be 1, -1. This would be 2, 0. And this would be 5, 1. All right, they're just the image points. Okay? All right, derivative. Well, you guys, derivative is slope, so check it out. What's the slope at -1? Well, it's 3/2. What's the slope at 0? It's 2. What's the slope at 1? It's 1/2. What's the slope at the inverse of each of those points? 2/3, 1/2, and 2. Okay? So now I can figure out, I can answer all these questions, right? G prime of 1 means the slope at 1. That's 2/3. G prime of 2, the slope at 2, that's 1/2. G prime of 3. Not possible. Notice it said if possible. I was like, what? Yeah, G prime of 3, like we can't find that. All right. G prime of 0, also not possible. So don't get messed up and be like, ooh, there's a 0, because that's not the right point. That's the y coordinate, not the x coordinate, right? So that one's actually not possible. And then this last one, G prime of 5, oh yeah, we got that. That one's going to be 2. Okay, so a couple of these weren't possible. We just didn't have the information needed for that. Okay? Okay, here is like exactly the type of questions that we will be doing with these, okay? It's just literally the only example on this whole thing. Holy cow. All right, so we're going to have to do a lot of stuff in class. Okay, sorry, just going through there. This is exactly how this works. Now, I told you I have a trick because sometimes I get messed up. You don't have to do this, but here's what I'm going to do. Sometimes I do this. I go let, and you have to, if you're doing this on the AP test, you have to let the graders know what you're doing. Let inverse equal G, because I just get so freaking messed up. So here I have my information about f of x, and then here it wants me to find G prime of 28. Okay? So here's how it works, right? I start by setting it up. I go like this. G prime of something is 1 over f prime of something. And then I go look for what I call magic point, okay? Magic point is this point right here. Because this point says if f of 3 is 28, I can make another conclusion out of that. I can say, well, that means that G of 28 has to be 3, okay? If f of 3 is 28, G of 28 has to be 3. Make sense? And so if I'm finding G prime of 28, okay, because that's what it's asking me to find, it's 1 over f prime of 3, because that's like magic point, right there, the inverse point. And now I can actually do this problem, all right? Because can I figure out what f prime of 3 is? I mean, I have no information about G. I can't find the inverse of it. But I could find f prime of 3, all right? So check this out. All right, f of x is x to the third minus 2x plus 7. The derivative of that is 3x squared minus 2. So the derivative at 3 is 3 times 3 squared minus 2. That's 27 minus 2, that's 25. So this is 1 over 25. This makes an extraordinarily good multiple choice question. Okay, sorry, I didn't see all that. My big face was in the way. That makes a really, really good AP multiple choice question. All right, so let me show you guys a couple examples of that. You don't have to write this down, just watch for a sec. All right, guys, check it out. F and G are inverse functions that are differentiable for all of x. If f of 3, oops, I'm trying to get this on here. Where is it? There we go. Okay, if f of 3 is negative 2, and G prime of negative 2 is negative 4, which of the following statements must be false? It looks like it gives me no information here, okay? All right, let me just look at this, and we'll just say true or false next to it, all right? Okay, so let's start with f prime of 0. All right? F prime of 0 is 1 over G prime of something, all right? And there has to be a point in there. And you know what, you guys? I see nothing with a 0 in it, nothing at all. So I'm going false on that bad boy. Okay, let's look at this next one. F prime of 3 is 1 over G prime of something. Okay, cool. F of 3 is negative 2. That's magic point. Because that means that G of negative 2 is 3. F of 3 is negative 2. So F prime is 1 over G prime of 2, which is going to be 1 over, and this tells me that G prime of, oh, I'm sorry, that was supposed to be negative 2, is negative 4. So F prime of 3 is negative 1/4. That's so true. That's so true. All right. Let's see this one. F prime of 5. Well, that's got to be 1 over G prime of something. I have no information about 5. That's false. Okay? So there's a good example of, so 1 and 3 are false. So on here, I would be like 1 and 3 are false. Okay? All right, let's see if you guys could do this AP question. Okay? This is an AP question directly off of, this was the 2003, I believe. I just pulled this off of the interwebs. This is from the 2003 AP test. Okay? All right. Let f be the function defined by f of x equals x to the third plus x. If g is the inverse of x and g of 2 is 1, what's the value of g prime of 2? This is cake, you guys. This is so freaking cake. Look. If g prime of 2 is 1 over f prime of something, and I look for magic point, and it actually gave it to me. You know, a lot of times it will tell me, like, f of 1 is 2, and you have to yourself go, oh, that means g of 2 is 1. But it freaking gave that to me, like, right there, which is crazy. So all we have to do is find f prime of 1. So we go, okay, well, the derivative is 3x squared plus 1. If I plug in 1, I get 3 times 1 squared plus 1, which is 4. So this is 1 over 4. Notice one of the detractor answers, right, is just 4 if you forget to do that 1 over. So, yeah. Okay? But easy dubs, right, guys? All right, cool. Hopefully you understood this lesson.